This is the third video on section 5.2, limits and continuity of functions of several variables. So here we're going to look at the limit as xy approaches 0, 0 of x squared times y to the fourth divided by x squared plus y to the fourth. Once again, we have an indeterminate form of type 0 over 0. So let's explore this a little bit like we have done with the previous functions. We'll take the limit as xy approaches 0, 0 along the x-axis. We have 0. We'll take the limit as xy approaches 0, 0 along the y-axis. We get 0. We take the limit as xy approaches 0, 0 along the line y equals x, and we still have 0. This x to the 6th divided by x squared plus x to the 4th going to 0. You could do this from Calc 1 or Calc 2. So for Calc 2, you could take L'Hopital's rule as many times as necessary to get to the 0. We can factor an x to the 4th out here and cancel. There are just different ways to see that this is 0. But this is a Calc 1 / Calc 2 problem right here. Speaking of that, why does this go to 0? Because what happens here is we have a 6th degree polynomial going to 0. We have a 4th degree polynomial going to 0. The numerator is trying to take this fraction to 0. The denominator is trying to take it to infinity. Because when you take, say, a constant and divide by something going to 0, that goes to infinity or negative infinity. That's what this term is trying to do. But this is a 6th degree polynomial. This is a 4th degree polynomial. So the 6th degree polynomial wins. So that's why this limit is 0. So considering that, here we have a 6th degree polynomial. Here we have a 4th degree polynomial. Perhaps the 6th degree polynomial is going to win. So perhaps this limit actually is 0. I should say at this point it can't be anything else. Okay? So this limit either doesn't exist or it is 0 because each one of these limits is 0. Once you calculate one of these, that means this limit is either 0 or doesn't exist. And it turns out, in fact, that the limit actually is 0. So we want to prove that. We can't just say, well, we have a 6th degree divided by a 4th degree and the 6th degree wins. So we're going to use the epsilon delta definition of limit to prove this. So let's let epsilon greater than 0 be given. And now we get to choose our delta. We're going to choose carefully. So we're going to choose our delta greater than 0 such that delta is less than epsilon, but also that it's less than 1. We're going to use both of those in our sequence of inequalities. So let's suppose xy is in R2. The distance between x, y, and 0, 0 is less than delta, but they're not the same. So we're taking our point xy, that's close to 0, 0. This is what we mean by close. Their distance is less than delta, but they're not actually equal. We need the fact that they're not actually equal here, okay, because this function's not defined at 0, 0. So we have to be sure that this point's not the origin. Then what happens? Well, let's look at our inequalities. We have our function value minus this alleged limit here, an absolute value. We want to show that that's less than epsilon. That's our goal here. Well, subtracting 0 doesn't do anything to our term, so we just have this thing inside of an absolute value. We can factor out the x squared. Factor out a y to the 4th if you wanted to. But we picked 1, I picked the x squared. Remember that the absolute value of the product is the product of the absolute values. Doesn't work for summations, but it does work for products. So the absolute value of a times b is the absolute value of a times the absolute value of b. The absolute value of x squared is x squared. So we can factor the x squared out. This is less than or equal to just x squared by itself. Why? I have the explanations in parentheses along the side. It's because this part is less than or equal to 1. We are taking y to the 4th and dividing by y to the 4th plus a non-negative number. X might be 0, but it can't, or x squared might be 0, but it can't be negative. Now, x and y can't both be 0 at the same time, but either one of them could be 0. So this is less than or equal to 1. Y to the 4th divided by y to the 4th plus a little piece here. That's less than or equal to 1. x squared is less than delta squared. Why? Because the absolute value of x is less than delta. Why? I'll explain at the end. So I'll explain this thing right here in the end. But assuming you believe that, x squared is less than delta squared because the absolute value of x is less than delta. Delta squared is less than delta because delta was chosen to be smaller than 1. The square of a number smaller than 1 is smaller than the original number. Delta squared is smaller than delta because delta is smaller than 1. And delta was chosen to be less than epsilon because, where do you say it? Yeah. Choose delta greater than 0 such that delta is less than epsilon. So that was chosen. Let's go back to the one thing I haven't quite justified yet. Why is this true? Well, what does this mean? This thing right here. The distance between x and y and the origin less than delta, it means that the point xy is in the interior of the circle centered at 0, 0 of radius delta, which I've drawn right here. Here's our circle centered at 0, 0 of radius delta. X and y is the point xy is inside that circle, but not 0, 0. So xy lives in here somewhere. Look at this circle, it has radius delta. So this is the point delta 0, this is the point 0 delta, negative delta 0, 0 negative delta. Wherever xy is, and I just kind of put the x right there, it's somewhere along here. Its absolute value is less than delta because the point xy is on the interior of that circle. So x has to be strictly between negative delta and delta. That's why the absolute value of x is less than delta. And so this is the end of our proof. And so this limit is in fact 0.